The next section, 1.3.8, will be about buoyancy. Okay? When the object is submerged in a fluid, we know that buoyant force is exerted on the object. Okay? The famous Archimedes principle says that the buoyant force exerted on the object will be equal to the weight of fluid displaced. But why? Let me derive it. Okay? So remember the graph that we have used to determine the hydrostatic equation. Okay? Let me redraw that here. Okay? I have redrawn the graph, okay, that I have used to derive the hydrostatic equation. Okay, so how can we find out the buoyant force? Okay, well, suppose we have a rectangular object put into this position. Okay, the fluid here would be replaced by this rectangular object, and originally the rectangular fluid element, okay, because it has a weight here and it is balanced by the pressure force around this fluid element. So if you replace this fluid element by a rectangular object, then the buoyant force should be the force that balances the original weight of the fluid. Okay? The buoyant force, you can write it as delta P times the area. Okay? Delta P, we have derived that will be rho G delta Ez times A. Okay? We can rearrange it a little bit so that A delta Ez will be grouped, and here it will be equal to rho G times volume. Okay, rho GV. Okay, and this equation is also applicable for any object because you can just divide the object into infinitely many small cuboids, so that you can also find out the buoyant force by summing up all of the buoyant force acting on the cuboids.